motion. Do you think Newton's laws of motion are applicable only in the place where Newton lived? The answer is no. So the theory has the utility or applicability all over the world. Then experimental research. You know, COVID-19, this came and different countries, they started working on it and trying to find out the solution of this particular problem. And they did experiment and they came out with vaccine. And the vaccine was applicable only within that particular country. Then they started finding out whether it can be used in other country or not. But that is so. Therefore, the experimental research is the utility or the degree of applicability is limited. For example, if you have your mobile and you are in India, if you come to US, then your mobile will not work. You have to change your SIM card, or you have to have the international roaming facilities on your mobile. Without it, your mobile will not work. Say if you have a fan, in India, the fan works at 220 volts. But if you take it to Canada, it will not work, because in Canada, it is not 220 volt, it is 110 volts. So if you want to use that fan in Canada, then you have to have a step up transformer, because the step up transformer will change the 110 volt to the 220 volts. So therefore, whatever you have, the fan in India, it has a limited utility. It's not outside. You know, in India, we have a left-hand side driving, and in US, they have a right-hand side driving. If the US people, they want to manufacture the car which can be used in India, then they have to change the steering from their right-hand side to the left-hand side. Without that, it will be difficult for Indians to drive. So therefore, the experimental research has got the utility or applicability which is lesser than the theory. Action research is the problem. Wherever the problem is, you have to find out the solution of the problem, keeping in mind that situation, and use the solution only there. Say if I have a fever, then the doctor will give me the medicine keeping in mind my different say characteristics. He will ask me, are you feeling like this? Are you feeling like this? Whatever answer I will get, then accordingly he will judge that what might be the problem, and he will give me the. If another person is having the fever, he may not give the same medicine which he gave to me, because his fever may be because of something else. So therefore, you can say all these, the answer is that you can differentiate them, the degree of utility, or you can say the applicability. These are the answers of the two questions. I hope you have understood. Now we go ahead. Now, dear friends, till yesterday, I have done the t-test and correlated t-test. And now you know that the t-test you can use only when you have one variable having two groups, two independent groups. And if you have more than two independent groups, then t-test cannot be used. Now, the paired samples t-test can be used only and only when you have one group and you have pre-tested and given the treatment and post-tested. If you have two groups where you are giving the treatment, then you can't use the correlated t-test. Then some other test has to be used. Now I'm going to take you to the another one, and now I'm giving a analysis of variance. If Mr. Mattu has come, Mattu, say hello to me. Mattu. Mattu, are you there? No, don't worry. Now, it is also short form is ANOVA. Now, in this one, the assumption is that the normal distribution this is the one. Another is homogeneity of variance. And here you have more than two groups. So it is the standard deviation the square of the standard deviation will become the variance is equal to is equal to is equal to so you may have more than two groups, and all these three, all the groups must be independent. So another is that there must be more than two independent groups. Because if you have the two groups, two independent groups, then you can use t-test, or even if you want to use one way ANOVA, you can use one way ANOVA, no problem at all. That is up to you. Then there must be one discontinuous variable having two or more levels. Then there must be one continuous variable. And I need not to tell you that continuous variable means variable having the data either on the interval scale or on the ratio scale. That is data must be either on interval scale or ratio scale. Then there should not be any outlier. There should not be any outliers. Now, these are the assumptions which your data should fulfill whenever you want to analyze your data with the help of analysis of variance. Now here, see, I have said that there must be two independent groups. When I've said there must be one discontinuous variable having two or more level. See, here I have said one discontinuous variable. Having two or more levels. So because it is one discontinuous variable having two or more levels, so this is called one-way analysis of variance. So therefore, I'm now going to tell you one-way analysis of variance. Because there is one discontinuous variable having two or more than two levels. Now, let me take one example. Mattu, you were asking me yesterday. So let me tell you that. No problem, Lokesh. Do not worry about it. Whatever advantage you can take, you take it. Mattu, yesterday I was telling you that there are standard tables. Here is a standard table for the t-test. So similarly, there will be a standard table for analysis of variance. There will be standard table for chi-square. There will be standard table for correlation. And you have to compare your calculated value with the standard values which are given here. And in these standard values, you will have, these are the level of significance: 0.20, 0.10, 0.05, 0.02, and 0.01. These are the level of significance. And this is the degree of freedom. So in order to find whether your calculated value is significant or not, you need both. Number one, degree of freedom, and you must have your level of significance. Without these, you cannot find out whether your calculated value is significant or not. So therefore, this is the point which I thought I must tell you. Age is a continuous variable. Age is a continuous variable. It is not discontinuous variable, because your age may be 20 years, maybe 20 years, 5 days, maybe 20 years, 6 months. So it is a continuous variable. Lokesh, you can ask Dr. Gupta, he will provide you the recording of my lecture. So I hope you have understood. Mattu, Mr. Mattu, have you understood what you wanted yesterday? Okay, so we go ahead. So now I am taking one particular variable. So you can give me any variable you like. Name the variable which you want me to take, a continuous variable. Suppose I am taking one variable. Okay, let me take variable anxiety. I am writing the title. A study of anxiety of teachers. Do you want teachers or do you want students? Do you want teachers or students? A study of anxiety of teachers of private colleges of Noida. UP. Say this is my title, and in this title, you know, this is what is variable. So your title must have a variable. So variable here is anxiety. And then your title must give you your population. your population is teachers of private colleges of Noida, UP, and then you know your method of research, and it is the survey method. So your title must give you these three informations. And if it does not give these three informations, then your title is not all right. Now, if you write like this, now if you write like this, the title, is it all right? A study of anxiety of teachers of private colleges. Is this title okay? Now you have started understanding. So this title is not okay. Very good. So therefore you have to write the place, whether it is Maharashtra, whether it is say Guwahati, or whether it is Agartala, or whatever it is. The place is very important. So therefore you cannot have like this. Now, let me write the objective. In this particular case, the objective is here. It is a study of anxiety of teachers of private colleges of Noida, UP. So I have to have the three groups. And the objective is to compare mean scores of anxiety of arts, science, and commerce teachers. So I have to have the three groups. So I have taken the three groups as arts, science, and commerce. And if this is my objective, then my hypothesis is I can copy this much and I write there is no significant difference in mean score of anxiety of art, science, and commerce teachers. Now, if this is my hypothesis, now let me enter the data in the SPSS and analyze it. So can you tell me from this objective that what are the variables related to which you will be entering the data? No, Lakshmi, I will tell about the experimental. Whenever we do experimental study, I will tell you. Don't worry about it. Ashok Malhotra, your answer is correct. Rashi, answer is correct. Swati, answer is not correct. Sojane, answer is not correct. Siddiqui, do not write score, only write anxiety. Anxiety is the variable. Types of teacher is not the variable. Okay, so here there are only two variable. One variable is a anxiety, and another you can say stream, or you can say discipline, arts, science and commerce, or you can say subjects, arts, science and commerce, whatever you, or you can say faculty, arts, science and commerce, anything. So these are the two variables. So we go to SPSS. Yes, Dr. Rachna, you are is correct. I hope you can see this particular file. Now, I first of all go to the data view. Are you able to see this file? SPSS. Okay. So we go to the variable view, and here I write whatever you want. If you want stream, I can write stream, and stream is a discontinuous variable having the three levels. So label is 3, and under value we will write 1 if I say arts subject. Then I say 2 is science subject. 3 I say commerce. You can write any subject first, but whatever the sequence in which you have used while writing objective, try to follow the same sequence. In the objective, I wrote art first, then science, and then commerce. So I have to follow the same sequence. But if I write commerce, arts, and science, then I have to have that particular sequence. So this you should understand. Now next is anxiety. And anxiety is continuous, so therefore I have not to do anything. Stream is discontinuous because arts, science, and commerce. Can you have anything between arts and science? Matto, your weight is a continuous variable because you can have 50 kg weight, 50.1 kg weight, 50.5 kg weight. It is continuous. Matto, because these are three different. Arts is different, science is different, and commerce is different. So these are three different, like male and female. So gender is a discontinuous variable because you have male or you have female. So this is how we have to. Now let us go to the data view. Now here you can have any number of the arts. You may take any number of the teachers in arts. maybe 20, maybe 30, maybe 15, it doesn't matter. So number of the arts teachers, number of the science teachers, and number of the commerce teachers may not be the same. It may be different. So here, let me write 1. You may have even mixed also, no problem. But I am, for your understanding, I am putting that first. So I have entered the data of the stream first. And now I am entering the data of the anxiety. And there is an anxiety scale. And in this anxiety scale, you will have numbers. No, Navita, anxiety scale doesn't have nominal scale data. It is wrong. It will have interval scale, because there you will have a scale like strongly agree, agree, undecided, disagree, and strongly disagree. Okay, let me repeat it again. That this is the stream. In the stream, this is the label. So under the label, I have written 3. And then I went to the values. And in the values, you see these are the 1. So let me remove all these and then enter again. So I am under the value labels. Here is a value. So I say 1. 1 is the code. And I say here arts teachers. And I add. Then I say 2 is a science teacher. And then here I say commerce teachers. And then I say okay. So this is how you have to enter. Navita, in the stream, you do not worry. If you want to put nominal, you can put. If you do not want to put, it does not matter. Navita, it does not matter. Now in the data view, now you click on the data view, you have this sheet. And now here you have to enter the data. So I have already entered the data of the stream. I have already entered the data of the stream. And now I am entering the data of the anxiety. So if my anxiety minimum score is 5 and maximum is 30. So let me enter the data. So now I am entering the data. I'm just entering the data like this. Okay, I've entered the data. Any question, any participant like to ask? Now, I have to go to analyze, and then I go to the compare means. And in the compare means, can you see one way ANOVA? Somaya, whatever the data you have, whatever the data of the anxiety you have to enter exactly the same data. So nothing to worry about it. Whatever I have written, this is I do not have a data. So this is how I have written. So I go to analyze, then I go to compare means. Because my objective is to compare mean score of anxiety of art, science, and commerce teachers. So therefore, I come to the compare mean, then I come to one way ANOVA. Are you able to follow this? And then I am okay. And then here is a dependent list. And here is your factor. Your stream is a factor because it is discontinuous. And your dependent will always be continuous. So you can shift anxiety here. Mattu, you can have anyone you like, nothing to worry. In the SPSS is a very, very, very big. So you can have as many cases as you like, no problem. Now, after this, you see the option. In option, you have descriptive, means mean and standard deviation. Do you want? Yes. Then it is a fixed and random effect. Let us have this. I will tell you what it is. And then homogeneity of variance test. If you want, you can have that also. And now you continue. Now the post hoc. In this particular case, we have the three groups. And if your F value is significant, then it will indicate that the mean score of anxiety of arts teachers, science teachers, and commerce teachers differ significantly. But it will not tell whether the mean score of anxiety of science teacher is higher than that of arts and commerce teacher or not. In order to know that, you have to have the another one, and that is post hoc test. So either you can use post hoc test, or you can use the t-test. So do you want to use the post hoc test? I will do Samay. Sojanya, please wait. I have read your answer, your question. Please wait. So here you can use the Duncans. There are equal variances assumed and equal variances not assumed. So if it is, I am saying equal variance is assumed and it is Duncan. There are 12. 6 on this side and this 6 on this side, 12. So many are there. So you can use anyone that fits in your own case. So we say continue. Okay, Sojanya, I am explaining to you. You first go to analyze, then come to compare means, and then come to one-way ANOVA. And now you click it. You will get this dialog box. In the dependent list, you have to shift the anxiety because it is a continuous variable. And under factor, you have to shift the stream because it is a discontinuous variable. So Jania, have you understood up to here? So Jania, and now you go to options. And in the option, if you want descriptives, you can highlight it. If you want fixed and random factors, you effect, you can highlight it. If you want homogeneity or variance test, you can highlight it. No problem. And then you can say continue. Now in the post hoc test, because here we have the 3 groups, 3 independent groups. So it is quite possible that my F value may be significant. And if it is significant, then it will indicate that the mean score of anxiety of arts, science, and commerce teachers differ significantly. But it will not tell whether the mean score of anxiety of arts teachers is significantly higher than that of science and commerce teacher or not. For that, you have to do a post hoc test. And there are many. There are 1, 2, 3, 4, 5, 6 on this side and 6 on this side. So you can use, I am using Duncan's. Its complete name is Duncan Multiple Range Test. That is the complete name. So the post hoc test is to be used only to find out whether the mean score of anxiety of arts teacher is significantly higher than that of science and commerce teachers or not, or the mean score of anxiety of science teachers is significantly higher than that of arts and commerce or not, etc. Either you can use post hoc test or you can use even t-test. So whatever you like, I will do that. Do you want t-test or do you want post hoc test? You can use but to another also, no problem. If you want LSD, you can have LSD. Do not worry. You can have anyone you like. So I'm having LSD and Duncan's, and I say continue. The significance is already 0.05. So I'm not changing. I say continue. Now, in the contrast, this is polynomial. It is not to be used here because I'm not interested in finding the trend. I cannot find the trend. So we say okay. Now here you can say the homogeneity of variance. Here this is 8.4% error. So this Levin's statistic is 2.569 and here error is 8.4%. And this error is more than 5%. The meaning is whatever are the differences of anxiety in the arts group, the same differences are in science and the same difference in commerce. So my homogeneity of variance condition is satisfied. Now this is my F value. And this F value is significant. You can see here 0.000. So that means the level of significance is 0.01. So that means my F value is significant. And this is my post hoc. This is the LSD least square distance, and this is Duncan's. So let us proceed further for interpretation. Any question you want to ask here? Any question about the analysis? If no question, then I'm proceeding further for interpretation. So I have copied this ANOVA because I need these. So let us, this is my objective. This is my objective. And here, if homogeneity variance is significant, then it means your condition of homogeneity of variance is not assumed. Dr. Ashok Malhotra, the meaning is then homogeneity of variance condition is not assumed. No, you need not to. It does not ask anything like that. Sojanya, it does not ask. So now, yesterday, I told you it was 4.3.0. So now I'm saying 4. I think it was 4.4.0. Okay, it is. So let me write 4.5.0 today. Now here, can you tell me what will be the heading of this particular caption? Can you tell me the heading of this particular caption? No, Ashok Malhotra, it is wrong, beta. No, because you have written stream wise, then how can you write arts and science and commerce? It should be stream wise comparison of mean scores of anxiety of teachers. That's all. So that is the correct one. Stream wise comparison of mean scores of anxiety of teachers. This will be the caption heading of this particular objective. Now, then I say the fourth objective was to compare mean scores of anxiety of art, science, and commerce teachers. Now, there are 3 groups: art, science, and commerce. Art, science, and commerce were the 3. Were the 3 stream. So data were analyzed with the help of one-way ANOVA and the results are given in table 4.5. Here table 4.5. So let me insert the table here. Now here, now I have to write source of variance, because you know the variance means the differences. There are three sources of the differences. One source of the differences is because of the stream. And another is your error. And another is your total. So these are the three sources of variance. So I have to write source of variance. Then next will be my degree of freedom. Next will be SS. SS means sum of squares. Then is MSS. MSS means mean sum of squares. And then is your F value. So let us write the information from my SPSS. So from the SPSS, you see here is a between groups. But we have three groups. Actually, in SPSS, some of the words are fixed and you cannot change. But whenever you are developing your own table, you should write the correct name. So I will not write between groups, I will write streams. And here my degree of freedom is 2. Because I have the three groups. So 3 minus 1 is 2. So here my degree of freedom is 2. Then my error degree of freedom is 72. How it has come, I will tell you just now. Don't worry about it. And my total is 74. How 74, I will tell you. Don't worry about it. Now, I have to write SS, sum of squares. This value is 399.55. I need not to write up to the 3 decimal. I can write only up to the 2 decimal. Next is 360.93. I need not to write for the total. Now MSS. This 399.55 is to be divided by 2. And this will be 199.78. Because it is 776. So I can say 78. Next is 5.01. And then my F value is 39.85. Now how these values come, let me explain you. So in this table, value is significant at 0.000. So I will write 0.01. You need not to have any other information out of this. So I'm okay this. So if you want, you can write a double star here. And below you can say significant. And if you do not want to write the double star, if you want to write the remark, then you remove it and then you write here remark. And then you can say P is less than 0.01. But please remember P must be small. Now let us see what the heading of the table. it will be summary of one-way ANOVA of anxiety of teachers. This will be the table heading that you should write. Because here it is at 0.01, so I can write the maximum, no problem. So Jania, because it is 0.01 and 0.01 is higher than 0.05. So I can write the 0.01, no problem at all. Now, what is the SS? SS, you know, the full form of SS is sum of square. That is the meaning of SS. And the SS you will have the values which have been given. Now, MSS means mean sum of square. And here you will have the two mean sum of square. One mean sum of square for stream, mean sum of square for stream is equal to SH for stream divided by the degree of freedom of stream. And you know the SS for stream is 399.55. And this has to be divided by 2. And if you divide it by 2, it will be 199.78. This is how this value has come. Now it is mean sum of square of error. Is equal to SS for error is equal to degree of freedom for error. And here this will be 360.93 divided by 72. And it will come to 5.01. This is how the value of MSS has been calculated. So Jania, when your value is significant at a higher level, then you must mention that, because if it is significant at a higher level, it will be significant at a lower level. If your weight is 15 kg, then it means your weight is more than 49 kg. It is automatically understood. So this is how this value MSS was calculated. And now how do we calculate the value F? This your F is nothing. It is the ratio of MSS over the MSS error. So it is the ratio, and that is why 199.78 is to be divided by 5.01, and if you divide, it will be 39.85. So this is how this value was calculated. Now error, you know, when you take your weight is not the real weight. Your weight is equal to your real weight plus the weight of your clothes, etc., etc. So whenever you have any reading, in that particular reading, there will be some amount of error. You cannot do any experiment without error. And error can never be zero. There has to be some error. So this is how you have calculated this. So any question you want to ask here? Any question you want to ask here? And there is a standard table, Mattu. You have to compare this F value, calculated value, with the standard table value. And you will be taking these 2 degrees of freedom. One is 2, other is 72. Now let me talk about the degree of freedom. The degree of freedom for total is equal to your n minus 1. If you know your total n, this is the value which will indicate whether the mean score of anxiety of art, science, and commerce teachers differ significantly or not. So here my total sample was, you can see here it was 75. Total members were 75. So 75 minus 1 is 74. So this is how you have the degree of freedom for this. So it was 75 minus 1. So it is 74. And for the degree of freedom for stream is equal to the number of the stream. So there are 3 groups. 3 minus 1 is equal to 2. And my degree of freedom for error will be equal to the degree of freedom of total minus the degree of freedom of stream. So here it is 74 minus 2. And this is how it has come to 72. So this is how the degree of freedom for stream, error, and total have been calculated. Now, let us write the interpretation. Now, I am writing the interpretation, which is the most difficult, so you should try to understand. From table 4.5, it can be seen that the F value is 39.85, which is significant at 0.01 level with df equal to, there are 2 degrees of freedom which you have to mention. One for the stream, other for the error. So you can write like this, 2/72. This is the one way to write. Another way to write is Sachin, this my F value is significant. So whenever the F value is significant, the meaning is that the mean scores of anxiety of arts teacher, science teacher, and commerce teacher differ significantly. This is the meaning whenever the F value is significant. If the F value is not significant, then it means the mean scores of that particular variable of the group do not differ. So it is from here only. I have not to show you anything. Sachin, are you able to understand? So our objective. The objective is to compare mean scores of anxiety. So my objective is to compare mean scores of anxiety of science, of art, science, and commerce teacher. So I'm comparing the mean scores of anxiety of the 3 groups. Sachin, is it all right or not? So from the table, it can be seen that the F value is 39.85, which is significant at the 0.01 level with df equal to 2/72. Either you can write like this or you can write like this also, 2,72, but then you should put a bracket. So I always prefer to write like this. And then it is full stop. Thank you. Now, if the F value is significant, what is the meaning? It reflects that there is a significant difference in mean scores of anxiety of arts, science, commerce teachers. If F value is significant, the meaning is that the mean scores of anxiety of art, science, and commerce teacher differ significantly. So there is a significant difference in mean scores of anxiety of art, science, and commerce teachers. Now, what my hypothesis? Thus, the null hypothesis that there is no significant difference in mean scores of anxiety of art, science, and commerce teachers is. What should I write? Is rejected or is not rejected? So Janya, which value you want to see? So Janya, you have written, can we see the value? Which value do you want to see? So it should be rejected. So Janya, do not worry, do not worry, do not worry, do not jump. So Janya, if you jump, you will not understand better. You should go along with me. Okay. Now, so if your F value is significant, it will only indicate that the mean scores differ significantly or do not differ significantly. Now, because the mean scores differ significantly, then I am interested in finding out whether the mean score of anxiety of arts teachers is significantly higher than that of science and commerce teachers or not. So then I'll say in order to know which groups mean score of anxiety is significantly higher. In order to know which groups mean score of anxiety is significantly higher, the data were further analyzed. Now, do you want me to analyze with the help of a t-test, or we have already analyzed with the help of LSD as well as the Duncan's multiple range test? So do you want me to interpret the Duncan's multiple range test or LSD, or you want me to analyze with the help of t-test? What do you want? Okay, if you want Duncan, then we can say like this. Were analyzed with the help of Duncan's multiple range test. Okay, let me see first Duncan's. Duncan's multiple range test. And the results are given in table 4.6. So let me take here table 4.6. Let us insert the table. Now here is a stream. This is art, science, and commerce. Then I will have mean. Then I will have my SD. I will have my N. So let us go to my output. So this is the Duncan's. So let me copy, because I will be using now you say this is the mean score of anxiety of the commerce teacher. So I can write commerce. And here the mean is 16.65. Now next is the arts teachers. And here the mean is 18.76. Next is science, and here the mean is 22.27. So I have written the mean, and they do not have the standard deviation. They only have the N. Commerce is 26, arts is 25, and this is 24. This is just by chance. So now you see the commerce, the mean score of anxiety of commerce is significantly different from the arts. So here I will say arts. And this is significantly different, and it is, the difference is the 100, that means 0.01. So I can put a double star here. Then this will be the science. Now you can see that the commerce and the art differ significantly. The commerce and the science also differ significantly. The commerce and the science also differ significantly. This is arts and this is science. So arts and science also differ significantly. So they also differ significantly. So this is what I have written, because all these are different. So the commerce mean score of anxiety different from the arts and different from the science. the mean score of anxiety of arts is different from the science. Or you can say mean score of anxiety of science is different from arts and the commerce. Any way you can see. No, that is wrong. Sojanya, you cannot directly paste. It is wrong. Because there are many informations which you may not like to use it. So you cannot. It is wrong. You can see here, significance is 1.00. People will not understand what is the meaning of it. So, and you see so many other things are given. So I have already taken these values, and so therefore now I have to interpret. Now here I have to write stream wise mean and mean M and significance difference between mean scores of anxiety of teachers. Now from here, you can see from table 4.6, it can be seen that the mean score of commerce is 16.65, which is significantly lower than those of arts and science teachers whose mean score of scores of anxiety are 18.76 and 22.27 respectively. Now I need not to write the level of significance here again, because I have already written the level of significance for the S. You have not to write it here. Now it may be said that commerce teachers were found to have significantly lower anxiety as compared as compared to arts and science teachers. So this is the one which you have got the finding. Another is further the mean score of anxiety of arts teachers is 18.76, which is significantly lower than those of science teachers whose mean score of anxiety is 22.27. It may be said that arts teachers were found to have significantly lower anxiety as compared to arts teachers. Thus, commerce teachers were found to have significantly lower anxiety as compared arts, science teachers, but science teachers had significantly higher anxiety as compared to both arts and commerce teachers. Now this becomes your finding. If you have to write your finding, so this is your finding. So this is how you have to write the interpretation where have I written the, please see here is lower than that of arts and science teacher, the teachers whose mean scores are this and this respectively. It is correct. So it may be said that commerce teachers were found to have significant lower anxiety as compared to arts and science teacher. This is correct. Where Sojania have I written? Then you correct it. Don't worry about it. Further, the mean score of anxiety of arts teacher is this, which is significantly lower than that of science teacher, whose mean score is this. It may be said that arts teacher were found to have significantly lower anxiety as compared to, okay, here you say science teacher. No problem, you can make a correction. So thank you very much. So therefore, this is my finding. So if I have to interpret the Duncans, you should interpret only one, either Duncans or LST. You cannot interpret both. Now, if you want the t-test, then you can do t-test also. And you can interpret the t-test also. Is it clear now? So do you want me to analyze with the help of t-test also or no? Okay, so let me go to my SPSS. So this is my SPSS. If I go to my t-test, analyze, compare means, independent samples. So in the test variable, I have anxiety. In the stream, I have. So I have to take two at a time. So I'm taking the arts and the science teachers, 1 and 2. So this is the t value for arts and science. Now, so you have to do it 3 times. Now I say arts and commerce. So 1 and 3. So this is the one. And now I have to do for science and commerce. So 2 and 3. So this is how we have to write this. Now let us make a table. So you note down these values, mean and standard deviation. So it is arts and science. So note down, mean is 18.76, standard deviation 2.15. For the science, mean is 22.27, standard deviation 2.81, because 2.809, so you can say 1. And the arts is 25N and science is 24. There is nothing like repeated t-test. Dr. Sindiki, there is nothing like repeated t-test. That is wrong. Because if your F value is not significant, your T value may be significant. So when you have the one variable having more than 2 levels, you should never use the t-test first, because F test is stronger than the t-test. So you should always use the t test. You should always use the f test first. If your f value is significant, then you use t. Otherwise, you cannot use t. It is wrong. So now let me write these values. I have to make a table here. So let me insert a table here. So let me insert a table here. Stream. Stream is arts, science, commerce. So here I will be writing mean, then SD, then N, and then here I will be writing so here I will say arts and science. So here I can write science, and then here I can write commerce. So here the mean is 18.76, and here the mean is 22.27, and the standard deviation is 2.15, and another value of standard deviation is 2.81. And the N is 25 and 24. 25 and 24. And here the T value is 4.92. 4.92. And it is significant at 0.01 level. So I can say 0. Then next is arts and commerce. So it is arts and commerce. It is 16.65. 16.65 is the mean, and the standard deviation is 1.65. So 1.65, and here N is 26, and the T value is 3.93. 3.93, and it is significant. Then it is science and the commerce. The value, the T value for the science and the commerce is, it is 8.697. So 8.70 I can write. So 8.70, and it is significant. So I will write here significant at 0.01 level. And then here I say table 4.5. Stream wise, mean, SD, N, and T values of anxiety of teachers. Now, I have already told you how to interpret the t-value. So try to interpret the t-value, and then tomorrow I will interpret and you can compare it with my interpretation. So any question you want to ask before I say bye-bye to you? So the assignment is, please interpret the t-value, because we have already interpreted, so you know how to do it. Okay, Sojania, let me show you. This is your data. So we go to analyze, then go to descriptive statistics, and then go to explore. You go to descriptive statistics, then you go to explore, and you click it here. You shift anxiety in the dependent list. Then click on the plot. And then here is a normality plot. You click here. I hope, Sujanya, you are understanding. Is it okay? And now you say continue. And now you say continue. Now here you can say, according to Colme Grove, it is not normally distributed. But according to Wilk, it is normally distributed. Because it is, error is 11.7%. And according to Colme Grove, it is not normal because the error is 1%. So you can take it to be normal, no problem at all. And you can see that mostly all of these values are on the line, not much deviation from the line. So you can take it to be the normal, perfectly correct, nothing wrong in that. Is it clear, Sojania? Okay, so thank you very much for joining. See you tomorrow. And please do the assignment. The assignment, you should interpret the t-values. And see you tomorrow.